Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at how to automate visualization with the help of a wonderful library known as AutoViz library. Now, I'm using Googlecolab to run some of these codes. Ask any data scientist what is the toughest job while doing a data science project. And 9 out of 10 times, he's likely to reply that EDA, exploratory data analysis, is the toughest job while doing any data science project. Now, specifically in EDA, one of the most powerful weapons that a data scientist has is graphs. Now, you can do a variety of graphs. You can sometimes do a bar chart, you can do a pie chart, you can do a violin plot, you can do a KDE plot, you can do a box plot or a scatter plot. There are a wide variety of graphs that one can do. But imagine a data set which is very complex, wherein you have 50 variables. You have mixed data type. When I say mixed data type, you have a combination of categorical as well as numeric variables. When you have a mixture of categorical and numerical variables, how would you depict this visually? Would you do a bar chart? Would you do a pie chart? If you use all of these 40-50 variables for visualization, you may take 5 days or 6 days to run all of these plots. And some of these plots might make sense, some of these plots might not make sense. Now, the question is there a way in which we can simplify the process of visualization? In this direction, AutoViz library. AutoViz library is a great help to simplify the process of visualization. With this background, let me just explain some of the codes that I have written to construct different graphs using Googlecolab. In the first line of code, I'm just uploading a file that is present in my local machine. I have to choose the file. The file that I'll be choosing is known as HR file. This is quite a few variables, which I'll be showing in a few moments. The file has been uploaded. Right. I'll convert this file into a pandas data frame. I'll display the top 5 rows in this particular data set. So you can see here what the data set contains. You can see variables like employee ID. You can see gender of the employee. You can see education level of each and every employee. You can see the job category, salary, beginning salary, job time, previous experience, and whether the employee has churned or not. As you can see before you, you have a healthy mixture of categorical variables as well as numeric variables. Variables like gender, education level, job category, as well as churn. These are 5. In fact, I've got 3 + 1, 4 categorical variables. On the other hand, I've got 4 scale variables as well, like salary, beginning salary, job time, and previous experience. So for variables like gender, education level, job category, and churn, you can expect a bar plot. You can expect a stacked bar chart. These are some of the charts which are applicable when it comes to categorical variables. On the other hand, when you look at scale variables like salary, beginning salary, job time, previous experience, you can construct a scatter plot, you can do a PP plot, you can do a box plot, you can do a violin plot for all these scale variables. Now, imagine the amount of time it would take if you had to manually do these charts one by one for each of these variables. It would be a humongous task. It requires a lot of patience, it requires a lot of time, and it requires a lot of thought process. As I said, the AutoViz library that is present in Python simplifies the entire process of data visualization, and we can very quickly, efficiently, and in a simple, very simple way, expedite the process of visualization. To do this, all that you need to do is run 3 different lines of code. As you can see here, this is self-explanatory. In the first line, what I'm doing is I'm installing the library AutoWiz. In the second library, what I'm doing is I'm importing the class which is known as AutoWiz class. And finally, what I'm doing is I'm initializing the AutoWiz class. As soon as I run this particular snippet of code, it says requirement already satisfied. This is because I've previously installed this particular library. But in case you have not installed, please type these codes. You have to use a pip install to install the AutoWiz library. And the second line, what you can do is you can import AutoWiz class. And thirdly, you can just save an object AV by referencing this particular class, AutoWiz class. The final code that I'll be using here is to declare the file name here. The file name is hr1.csv. The separator is comma, and I can run the AutoWiz function on my data set. As soon as you run this in a span of seconds, you can see a wide variety of graphs. It takes some patience to explain some of these graphs, so please bear with me. You can see here there are a wide variety of graphs. Right. Now, as you can see here, the very first set of graphs, it is used a scale variable. So it is smart enough to recognize that beginning salary and salary, both of these variables are numeric variables. And since these variables are numeric variables, what it has done is it has done a scatter plot for it, right? My first impression is that there's a linear relationship. However, this is expected that these two variables share a linear relationship. If you look at the second graph to the right side, you can see in the y-axis we have job time, and in the x-axis you have the variable salary. I don't see any linear relationship as such. This is my first impression when I look at the distribution of these two variables. Let me scroll down. You can see it has done a scatter plot again for previous experience and salary. It has also done a scatter plot for job time and job time. My apologies, job time and beginning salary. The third set of graphs that you can see would be again between previous experience and beginning salary. It is showing you a scatter plot. It is also showing you a scatter plot for previous experience and job time. Imagine the amount of time, imagine the amount of effort that you would have had to put without AutoWiz. This would have taken around half an hour for you to sort of run through each of these combinations. This is not the end of it. Let me scroll down. Now here, I want to draw your attention to the variable under consideration. It is showing you three different graphs for the variable salary beginning. The first graph is a distribution plot, right? A distribution plot is nothing but a histogram. It's a frequency distribution plot that it is showing. And my first impression is that this variable beginning salary is not normally distributed. It is a skewed distributed variable. It is positively skewed. A box plot, the second chart that it shows is a box plot. And if the box plot further confirms that the distribution is not normal. You can also see a lot of outliers here as far as beginning salary is concerned. The third plot is very, very interesting. What it is doing is that it is doing a PP plot, a probability plot. Sometimes people refer to this as a percentile plot. Look at the distribution of the blue dots here. Had the distribution of the blue dots been along the red color line, you could have said that the variable is normally distributed. However, since the distribution of the blue dots is nowhere along the red line, I can conclude that the variable beginning salary is not normally distributed. So in one glance, you can see a histogram, you can see a box plot, as well as a probability plot for a scale variable. If you recall, I had 4 different scale variables. I had beginning salary, I had salary, that is the current salary. I also had job time and previous experience. And as I scroll down, you can see that AutoViz plot has plotted the histogram for the variable's previous experience. It has done a box plot as well as a PP plot for the second variable. Again, my conclusion is the same, that the variable previous experience is not normally distributed. It is positively skewed. There are a lot of outliers as far as this variable is concerned. Let me scroll down. I can see 3 plots for the scale variable. Again, when it comes to the variable salary, there is no normality. The variable appears to be positively skewed. There are a lot of outliers in this particular data set. This is the fourth scale variable that I have. I've got the variable job time. And what I see here is that the box plot appears okay. You don't have too many outliers, and it looks more or less normally distributed. However, I will have to change my opinion when I look at the probability plot, because when I look at the probability plot, there are some data points which are not lying on the 45-degree line, on the red color line, which means that I will have to further validate whether this variable follows normal distribution or not. My first impression when I look at the probability plot is that the variable, which is the variable that I'm talking about the variable job time. The variable job time is not normally distributed. So this is about the scale variables. It very, very quickly gives you a distribution plot, a box plot, as well as a PP plot. I'll scroll further down. Now look at this. This is what I do get when I have categorical variables. When I have got variables like clerk, managers, and custodials. These are the 3 categories that are present for the variable job cat, and it has given me the plot for all these 3 variables. When I scroll down, what I see in one glance, I see for all the 4 variables, it has constructed a violin plot. Now, violin plot is a very, very interesting plot, because it is a combination of a box plot on the one side and a KDE on the other side, right? You take a box plot and a KDE, combine it. What do you have is a violin plot. It is a perfect recipe. You have a clear recipe as for while constructing the violin plot. You take one part of a box plot, and you take not one but 2 parts of a KDE, a kernel density estimation plot. Combine these 2. What you have is a violin plot, right? A lot of the times people compare a violin plot with that of a box plot. There are a lot of similarities between a violin plot and a box plot, right? As you can see here, there are the first 3 similarities that I can highlight between a box plot and a violin plot is that both of them indicate the median. Both of them tell you the interquartile range, that is the difference between the 75th percentile and the 25th percentile. A box plot is very, very important, because a box plot shows you the outliers. But however, when you look at the violin plot basically with the help of KDE, it showcases the KDE, which references the PDF or the probability density function for the variable in the data set. This is about the violin plot. And as I scroll down, what you see is a heat plot. Let me show it to you. You can see the heat plot, heat map, my apologies. You can see the range here with the +1. If you have a value of +1, it means that there is a strong positive relationship. To the left side, you can see some of these variables having a high positive relationship. But as I scroll down, right, you can see there are a lot of values which have a moderate relationship, right? Some of these variables have a moderate positive relationship, but the black color here indicates that there is a very, very strong negative relationship. As the number tends to -1, there are more chances of the variables having a strong negative relationship. That is something which a heat map tells us. Let me scroll down to see if there are any other important graphs. Now, this is very, very important and interesting because here what you see is you see all the categorical variables what is the education level of each employee. This is in the x-axis, and the y-axis you can see the average salary, right? Interestingly, you can see people who have those employees who have done a diploma or PG, they tend to command a higher salary as compared to those employees who have done a UG or a high school or a pre-university, which is what we expect in our day-to-day life as well. Look at the second graph here. You have got education level in the x-axis, but here on the y-axis, I've got average beginning salary, right? You see the same kind of a trend, right? When a person has done diploma or postgraduate level of studies, he tends to have a higher average salary as compared to high school, undergraduate, or pre-university. Very, very interesting plots, and they start telling you a story. Let me just recall that when you firstly imported the data set by itself is dead, right? What is a data set? Data set is just a fact table. It does not tell you much. But the moment you do a visualization, the moment you do a EDA, and all these things are nothing but part of EDA, the moment you slice and dice the data set starts talking to you. So this is a great weapon in the hands of any data scientist. AutoVis library, and within a span of seconds, you can automate the entire process of visualization. Let me scroll further down here. When it comes to job time, for the different levels of education, I don't see too much of a difference because the height of the bars almost remains the same. But look at previous experience. There's clear difference for each of these 5 levels. For high school, when a person has completed his high school and pre-university, the average previous experience tend to be higher as compared to the remaining 3 groups. Further down, what it shows is that it shows the average salary in the y-axis, and it shows the different job categories in the x-axis. As expected, managers tend to be paid higher as compared to custodials and clerks. The same trend goes even for beginning salary as well. Managers tend to have a higher beginning salary as compared to custodials and clerks. Job time, there is not much of a difference. When it comes to average previous experience, the custodials are the ones who tend to have a very, very high previous experience. So you can see here, the moment you slice and dice the data set, the entire story behind the data set starts unfolding. One thing that I learned when I began my journey in this fascinating world of data science is, when it comes to modeling, you have 101 types of models like support vector machine, or you can use a deep learning algorithm or a linear regression, any of these techniques. But all these techniques come later. Fundamentally, one of the core ideas of data science is to do an EDA and uncover the hidden insights behind the data set. Here we can see a comparative study of the average salary between males and females. It is pretty self-explanatory. I can see the average salary of males tend to be around 40,000 as compared to females whose average salary is around 25,000, right? The same trend is repeated when it comes to the average beginning salary. Men tend to have a higher average beginning salary as compared to females. Let's look at average job time. There's not much of difference between males and females. When it comes to average previous experience, men tend to have, male employees tend to have a higher previous experience as compared to their female counterparts. Churn is a very, very important variable. The word churn basically refers to those people who switch companies, right? When you look at non-churners, their salary is higher as compared to those people who have churn. Very, very interesting. This is slightly counterintuitive, right? Something which needs further examination. The same trend is repeated for beginning salary as well, wherein those people who have not churned, they tend to have a higher beginning salary as compared to those people who have churned. On my second thoughts, it actually makes sense that when people or when employees basically are paid lesser salary, that itself sometimes could be a reason for them to churn. So in that sense, it's hardly a surprise that those people who have churned have had a lower salary as compared to their counterparts. Let me further scroll down. You are getting a comparative study between churners and non-churners when it comes to job time. Again, job time does not differentiate between these two groups. What about average previous experience? When it comes to yes category, that is the churners category, they tend to have a higher previous experience as compared to churners, right? So this is what I had for today's presentation. To just quickly recall, what we have done is we imported a file, right? We uploaded a file and then we imported a file. We looked at some of the variables. I had a healthy mixture of scale variables as well as categorical variables here. What I was able to do is I installed the AutoViz library, and I imported the AutoViz class. I initialized the AutoViz class, and in the next step, what I did is I sort of passed the data set. The data set that I'm working on is HR1, and you could see a wide variety of graphs. You would see around 25 to 30 different plots, very, very useful plots. It saves time. This particular library saves a lot of time. You can pick and choose those graphs which are relevant. You can ignore those graphs which are irrelevant, right? So AutoViz, I would repeat, is a very, very powerful library. It saves a lot of time and manual effort. 5 years back, or maybe even before that, if you had to do an EDA, it was the toughest task. But thanks to some of these libraries like AutoViz, and there are many other libraries which have sort of expedited the entire process of data visualization and EDA. I sincerely hope that you like today's presentation. I request you to subscribe to my channel, and I thank you very, very much for watching today's presentation. I'll see you in my next video. Thank you very much.